The area of the East Siberian Arctic Shelf is the most mysterious until recently area of the world ocean. It is about 2 million square kilometers, which is 1/3 of the continental shelf of the Arctic Ocean. And it is extremely shallow. The mean depth of this area is 50 meters. We register concentration of methane in the atmosphere of the Arctic region being 8 to 10% higher than above the entire globe. And this is called atmospheric maximum of methane. And the reason why this study started in the Chersky area was to somehow contribute, elucidate the reason for this atmospheric methane. We started out of this boreal forest area north to the subarctic and Arctic, and we found that the concentration of methane in the lakes decreased, as I told you earlier. But in the area of the coastal area of the shelf, we found one place where the concentration of methane was comparable to that we registered in this boreal forest lakes. And that was very interesting. What is causing this difference? Why is the concentration comparable? Because until recently, everybody thought that the Arctic shelf could not be a source of methane because it was considered that subsea water, being negative in its temperature, preserved this methanogenesis. So that was a previously widespread opinion. The permafrost, subsea permafrost, serves as a seal, as a cap, preventing any escape of methane from the seabed deposits. And when the permafrost failing in its ability to preserve these deposits any longer, so this high pressure has no obstacle. It just can be released as outbursts like and create this chimneys or pathway for this methane to release. The concentration of methane currently measured in the Arctic atmosphere are the highest ever measured during the last 400,000 years. Our estimates show that the methane venting from the East Siberian Arctic shelf is comparable to that amount of methane annually emitted from the entire world ocean. If at least less than 1% of those hydrate deposits will be decayed, destroyed, and released all the methane to the seawater and up to the atmosphere, this might cause increase in current atmospheric burden of methane up to 3-4 times. And this might cause climatic consequences, unpredicted. We have currently funded an NSF project, the purpose of which is drilling the permafrost all over the Siberian Arctic shelf, so that we can tell more certain how much is that potential of methane deposits preserved within the seabed to be released in the nearest future, in the remote future, and currently.